Now, if I ask most people, they'll say, oh, it grows from the ground. The roots go down into the soil and pull up material. It sounds reasonable. You look at a tree, it's got big roots going into the ground, and you think, well, obviously the tree is pulling stuff out of the dirt. But let me ask you a simpler question first. And this is the kind of question I like to ask because it makes you think about what you really understand. If trees really grow by taking material out of the soil, where are all the holes? Think about it. Go walk through a forest. You've got giant oak trees, pine trees, massive things. They've been growing there for 100 years, 200 years. If they were pulling thousands of pounds of soil out of the ground to make themselves, wouldn't there be huge holes all around the base of every tree? You'd expect the ground around the tree to be all sunken in where the soil had been removed. But it's not like that. The ground is perfectly fine. You can walk right up to the tree and the soil looks normal. That's strange, isn't it? That should make you pause and think. So where does the material come from then? Well, let me tell you about an experiment that was done a long time ago. In the 17th century, a Belgian chemist named John Baptist van Helmont did something very clever. He took a pot of soil. He weighed it carefully, very carefully. I think it was about 200 pounds or something. Then he took a small willow tree, weighed that too, maybe 5 pounds. He planted the tree in the pot and he watered it. That's all he did for 5 years. He just watered it. He didn't add any new soil. He was very careful about that. No new soil went in. Now, what do you think happened? The tree grew. It got big. He waited again after 5 years, and the tree had gained about 160 pounds. But here's the interesting part. The soil in the pot, he weighed that too. It had lost almost nothing. It had lost maybe 60 grams. That's it. About the weight of a couple of ounces, maybe less. The soil barely changed. So the tree gained 160 pounds, and the soil lost almost nothing. That's very, very strange. If the tree was pulling material from the soil, we should have seen a huge loss of soil, but we didn't. So where did all those 160 pounds come from? Now, Van Helmont at the time, he didn't know about photosynthesis yet. That hadn't been discovered. So he thought, well, I added water. I must have added a lot of water over 5 years, so the tree must be made of water. And he concluded that trees are made of water. But that's not quite right either, because we know trees are wood. They're solid things, not mostly water. Well, some water, sure, but not 160 pounds of water. So let's think about this differently. What are the possible sources of material? The tree needs to get mass from somewhere. What are the options? Well, the soil, but we just ruled that out. The water he added, that goes in, but the water itself isn't the wood. The light from the sun, well, light is energy, not material. Light doesn't have mass. You can't build something out of light. So what else is there? This is where most people get confused, because there's one thing that people don't think about as a source of material, and that thing is the air. Now, that sounds crazy. Air? You're telling me that a tree is made out of air? But think about it. The air is actually something. Air has mass. We know that. The air is sitting all around us, and it's made of different things. It's made of nitrogen, oxygen, and other gases, and one of those things is carbon dioxide. Now, here's the thing about carbon dioxide. Carbon dioxide is the gas that you and I exhale when we breathe. We breathe in oxygen, and our body burns fuel, and we breathe out carbon dioxide as a waste product. We're literally pushing carbon dioxide out into the air every single moment. And plants, trees, they do the opposite. They take that carbon dioxide out of the air, and they use it to build themselves. This process is called photosynthesis, and it's one of the most important chemical processes on Earth. Let me explain how it works, and I think it's really beautiful. A tree has leaves, right? The leaves have these tiny little structures in them. And in these structures, when sunlight hits them, something happens. The sunlight knocks electrons around, and the energy from the sunlight is used to break apart molecules. Specifically, it breaks apart water molecules. The water comes from the soil through the roots, and carbon dioxide comes from the air through tiny holes in the leaves called stomata. So the tree takes water and carbon dioxide, and using the energy from sunlight, it rearranges these molecules. It breaks the carbon dioxide apart, and it takes the carbon and combines it with water to make sugar. That's glucose. And the oxygen that was in the carbon dioxide, it throws away. It releases it back into the air. So we breathe in oxygen from trees, and trees take in carbon dioxide from us. It's this beautiful cycle. We need oxygen to live, and we make carbon dioxide, and the tree needs carbon dioxide, and it makes oxygen. We're literally trading with plants. Now this glucose, this sugar that the tree makes, it uses some of it for energy. The tree needs energy to live, to build new cells, to move things around. But a lot of this glucose it uses to build structure. It combines this glucose in different ways to make cellulose, which is the material of wood. That's what you're sitting on when you sit in a wooden chair. That's what a tree trunk is made of, cellulose. And cellulose comes from carbon. So when you see a big tree, most of that tree, and I mean the solid dry part, not counting water, most of it is carbon. That carbon came from the air. It came from carbon dioxide. The tree pulled it out of the air and made it into wood. And where did that carbon dioxide come from? Well, from us, from animals, from anything that breathes and dies and decays, or just from the atmosphere generally, where all this carbon dioxide is floating around. Now, here's something to really think about. If you take a tree and you burn it, you get energy. And carbon dioxide comes off. That carbon dioxide goes back into the air. So we take the carbon dioxide from the air, we make it into a tree, we burn the tree, and the carbon dioxide goes back into the air. It's a cycle. Matter doesn't disappear, it just changes form. So going back to our original question, trees don't grow from the ground, they grow from the air. The roots go into the ground, and yes, they pull out water and nutrients. The nutrients are important too. The soil has certain minerals and elements that the tree needs in small amounts. Nitrogen, phosphorus, potassium, magnesium, iron, these are important. But they're not the source of the mass. They're more like, they're like the tools or the helpers. The real building material comes from the air. The roots are really there to anchor the tree, to hold it up, and to get water and these trace elements. But the main growth, the main material that comes from the air, this is why the soil doesn't disappear. This is why there are no holes under trees. The tree is not mining the ground, it's mining the air. Now you might say, well, what about water? You said the tree takes in water. Yes, it does. Water is important. But water is a lot lighter than wood. And there's another thing about water. Water can also come from the air. When it rains, that rain came from water in the air that evaporated and condensed. So the water is cycling too. The tree takes in water from the soil, but that water itself doesn't stay in the tree forever. Some of it stays to become part of the wood, to become part of the cellulose. But a lot of it just passes through. The tree uses it, moves it around, and some of it evaporates back into the air. The tree is releasing water all the time. The leaves are wet with water that's evaporating. So if we want to be precise about this, we should say that the dry mass of the tree, not including water, comes almost entirely from the air, the carbon dioxide in the air, about 95%. Some minerals come from the soil, but it's a tiny amount. It's less than 5% of the dry mass. Let me give you another way to think about it. Imagine you had a very precise scale. You put a potted plant on it, you measure everything. You measure the plant, the pot, the soil, you measure how much water you add, you measure the light coming in, you measure everything. After a year, the plant has gotten bigger, you weigh everything again, the plant has gained mass. But if you add up all the water you've added and you add up all the soil, you'll find that the mass that's been added doesn't come close to the mass the plant has gained. The only way to explain that is that the plant has pulled material from the air, carbon dioxide from the air. This was very hard for people to understand when it was first discovered, because we're used to thinking about living things eating. An animal eats food, and the food has mass, and the animal incorporates that mass into its body. That makes sense. But a plant is different. A plant doesn't eat in that way. A plant takes in a gas that has very little mass individually, but there's so much of it in the air, and the plant takes it in and concentrates it. Thousands and thousands of carbon dioxide molecules all get built into the wood, and so the tree gets heavier and heavier and heavier. And here's something I find beautiful about this. The wood is essentially concentrated carbon dioxide. It's carbon dioxide that has been packed down and made into a solid. So every wooden thing around you, every table, every house frame, every piece of paper, it's all made from carbon dioxide that was once floating in the air. The tree pulled it out, humans used it, and now it's locked up in this solid form. If you burn that wood, it becomes carbon dioxide again, and it goes back into the air. The cycle continues. Now there's something else to consider. The soil, even though it doesn't directly provide the mass of the tree, it's still very important. The nutrients in the soil, they're part of the chemistry that makes the whole thing work. You can't make chlorophyll without certain elements. You can't make proteins without nitrogen. You can't make many of the compounds the tree needs without minerals from the soil. So the soil is crucial, but it's not the source of the mass. It's more like the helper. The air is the source of the mass. This is why I said at the beginning that trees don't grow from the ground. They grow from the air. The roots reach into the ground, sure, but the building material comes from the air. The tree is building itself from the carbon dioxide you and I are breathing out. Isn't that something? We're connected to plants in a way that we don't usually think about. You know, what I find most interesting is that this is not some mysterious process. This is chemistry. This is the rearrangement of atoms and molecules following chemical laws. Photosynthesis is just chemistry. It's atoms being rearranged. Carbon atoms, oxygen atoms, hydrogen atoms being rearranged according to the laws of chemistry. The sun provides the energy to do the rearranging, but the atoms were already there, in the air, in the water, waiting to be put together in a new way. So the next time you walk through a forest or you see a big tree, think about this. That tree is made of air. That wood that you're looking at is frozen carbon dioxide. It's carbon dioxide that was once a gas floating around in the atmosphere, and now it's a solid wood because the tree took it and rearranged it. And someday it might be burned or it might decay, and the carbon dioxide will go back into the air, and another plant might take it up and make itself into wood again. We're all part of this cycle. We're all connected through carbon, through the air. And that's why the answer to the question, where do trees grow from, is not the ground. It's the air. The whole tree is made of air. Beautiful, isn't it?